Hi, I'm Demon and welcome to hell. Today we've got this 16-inch auger housing to repair. Looks like it got hit straight on and has been held together for, I would say, maybe a couple of years. Oh, well, let me find some fine metal filler here. Just let me peel that off. Boop. Does anyone know what kind of metal filler this is? I think you know the answer to that question. But anyways, we have to replace this section because of its patches. We know that the auger has worn out the material inside and become paper thin. So now it's not a matter of straightening out, it's a full replacement. Come watch and I'll show you how I do these type of repairs. It's 16-inch. This is where you get to see me shard up like that. Hey everyone, Demon again. Sorry it's been taking a while to post any current videos, but I've been extremely busy and now I have my film crew here so we can document what's going on. We finally hit breakup, and what breakup means is when all the ice breaks free of the river and all your debris is going down and the river starts opening up for, well, what years ago would have been shipping and bringing new product in, but now in these times it means that, you know, the ice bridges wash out, the ferries can cross, supplies can reach, the ground thaws, farmers can access their land, and now they're looking for their equipment to be repaired and ready to go. Today I got a outshoot or final extension of an outshoot for a 16-inch auger on I believe a John Deere combine. But this tube here itself is worth new like $3,000. So he brought it to me to save himself some money and get back to work. So we're going to show you the process and what I take to turn this into this again. So first of all, we're going to have to really look at it and see what area needs to be replaced. Just as a rough look, I'd probably be cutting here. And to make it easier, I mean, one of two things: we can make a new patch that's an oval, so a big oval, to control the amount of warpage that will happen to that tube. Because sometimes if you go a straight square section and fold it over, it can get, you know, rather kinky here. You know, all you welders know what I'm talking about. It just goes because you have the pull of the weld to deal with. So if you want to limit that, and usually the best option is cut a big oval. So we are just going to figure out what the extent of the damage is on either side. Eyeball it, because remember we can peen. That's where we go from. Because if you look at the damage on a round tube, a crease, the pattern is actually an oval. So, I mean, if you want to repair it that has less stress and less pull to it, then you would cut out an oval. But in this particular damage, I think that's going to work best. Other scenarios, you don't really have that choice, so you got to look at each piece of metal and just and listen. And then fix it. Steel whisper. Now that I've mapped everything out and that I know the approximate size of the repair area I gotta do, it's gonna be shape of a 36 by 17.5 inch oval, and I'm gonna draw that out and cut it out of 16 gauge plate and form it to fit, and then we'll slide it over top and trace around it, pop it out, and trim to fit. So, tip number one, always keep your chalk sharp. I like the flat edge on the flat edge. Makes it easier when you line stuff up or cope or mark. Anytime I make any marks, I always go to a sharp V and then 2 marks all the time, and then draw through the center of the V. This decreases your accumulated error within your layout. And some people prefer chalk, some people use pencil, some people even prefer silver markers, the little thin flat ones. They're nice. The biggest advantage of a silver marker is if you have any wet surfaces or kind of oily, then the marks stay. Chalk, if you have any wet surfaces, or if you heat it up and sweat the steel, you can tend to lose your marks, whereas the silver marker stays. Accuracy in every step makes for a better product. Makes for a better weld, better fit up. And then in the end, if you do every step perfect, it just looks gorgeous when it's done. But if you take a whole bunch of muddy, crappy steps, you're going to end up with exactly that. Keep that in mind. If you're wondering why I'm laying this out in a rectangle and putting a crosshairs on it, it's one to mark the fork corners of my oval, to center punch them so I can line it up with my repair marks. In addition, once the oval's cut out of it, a key in recycling or always trimming and using your plates wisely is every time you're done, finish with a straight edge. You know, if it takes a little longer, map it out, cut the sheet off, or cut a nice square. Anytime anything is nice square edges, that plate is going to be used first, versus plates that have circles and ovals and sharp edges everywhere. You don't want to pull that out and you're like, let's go for a square plate. That's instinct, what everyone does. So if you want to always use your material faster, make sure you finish off with a nice clean edge, clean up the slag, and get it ready for the next time you use it, because you'll save yourself first 5 minutes into the job rather than having to cut a new clean edge every time. Make life a little easier. Either grab a piece of pipe or grab a zip disc and get yourself the end radiuses. Makes it faster. And for here, I'm just going to grab a chop saw blade and get that radius. Remember, it's always good to use what's around you to make life easier. I mean, we've got these common shapes all the time. This may not give you the perfect size, but it gives you something simple and geometrically close. And the rest is art. Watch me draw an oval. You don't have to worry if it's not perfectly symmetrical, because you have to cut a pattern anyways, so we might as well, we know the shape, we'll cut it, we'll form it, and then you'll use this shape to run your cut. So it'll conform to whatever you have. So to save yourself a lot of time, you don't need to, mathematically measure it out perfect. As long as once you shape it and fit it, now you fit it to that size and cut it to that shape, and you take all the thinking out. This is how you can increase time in a repair. And the biggest reason for the oval, or the ellipse, is you're doing a repair on a pipe, and you want to decrease the amount of heat input in the pipe and control the distortion, and make sure the weld is equal on both sides, so you have a chance to control your heat and control the tube from either curling up or curling to the side or kinking in the middle. Remember, an auger is going through this. You want it to be as round as you can, and by using an oval you can actually use the heat and the pull of the weld to tighten up and actually make it rounder. Get what I'm saying? Like when you tie it in and you got some bumps and some stuff over here, the contraction on the welds tighten up and make it rounder. That's what we're going for today. So let your work do the work for you. Does that look like a big eye? It's a private eye. Alright, since my new fancy Miller Elite has kind of crapped the bed, I gotta go back in time and do some cutting. Bad luck. somewhat square, throw it back in the rack, and it'll be first to get used. That looks clean all the way. Here's another way to get rid of the slag from the plasma. You can take a file, chip it off. You can take a scraper and chip it off. You can take a grinder and grind it off, or you can use an air chisel. It works actually pretty good. A little noisy, so if you're wearing earphones, turn up the volume. After I usually chip it, I like to just finish around the edges with a 40 grit flapper wheel. Works nice. One, to get rid of any rust or contamination, and then two, not to create any large gouges because we are dealing with 16 gauge plate. It'll make it quick. Now we clean up the edges, make it smooth. Now, best is always to put a device, or if you can, do it by hand. Sometimes I like to just go like this with one-handed. Problem is, most people doing that, you're gonna bling, bling, bling. You know, might not work out well. You can still do that, but this is how we do it a little safer. We grab two of these. They're called Bessie clamps. These ones are made by Stronghand. Really good. Had them for years. Not getting paid by Stronghand yet. But these are really good. I have like 20 pairs of them. I use them every day. And I think these were like $80 or $100 Canadian. Really good price. Really good tools. So, I know we're on a cutting table, but this one is made this way. Now, it's not going to go anywhere, and we can be here. You see, I don't really use a handle, but now I've freed myself up to use handle. But because I want to get close, I tend to just hold the back end away from me, so even if it kicks or moves, it's not coming into my face. This is what's preventing it, and then it's outside the radius of my arm. I'm not in here. If I slip, I'm not going to cut a piece off. And you don't need to go hardcore. Yeah, this is good enough to shape and work with. Don't have any major divots in the lines. Like I said, don't have to stress that it's absolutely symmetrical. Once you choose that side and form it, we'll lay our datum lines. And datum lines are lines of reference so that we can use it for lineup. I know that this line here is in the center of what I have on the auger, and the other one's the other way. So this will help you as you go. Leave your marks, and you'll actually gain time along your way. This is how you increase in speed, by thinking ahead and putting several steps in one, rather than having to go, oh, what side is it? Trim, and making a mistake. Now we'll put a center punch mark, center, here, and 5 spots. Notice how I hold my center punch, if no one's seen one. Kind of like a one-handed chopstick. You always put your middle finger down, and then you can position to the center of the punch. Alright, it's up. Now it's steady, and whack. And then you're good to go. Much easier. If you don't hold it right, you go, and then you're, and it ruins your good day. Now what I'm doing right now is I'm setting up for a horn, because I need to shape that shell. So I'm going to grab a piece of pipe, throw it on the table, and then I can shape it rather than making a big horn. I'll just forge it on a piece of paper. That's why sometimes it's good not to throw anything out. You never know when you'll need it. Remember, as a welder or a metal worker or as a blacksmith, anything you have to do, chances are you're going to have to make a tool to be able to do it quicker or faster if you don't have a roller or a forge. So up here, best tool you got. Use what's around you and do what you can to shape it. So now we're going to use a scrap piece of steel as our horn. I'm going to put a piece of angle either side and tack the angle iron to my plate, to my table, as well as the pipe to the table, and then that way it stays and I can shape the outer shell with a new shell rather than buying a new piece of pipe. But it still has to be shaped or made. Remember, you'll be cutting this off after. So, some people don't like it when you weld to the table. I find I like it because then you can put anything anywhere, but like anything, you have to maintain your table. See, we got a spot of splatter in this pipe that'll make it not sit correct and flat. So we'll clean that off and then tack it down. And if you're wondering why I'm doing all the grinding with this 40 grit flapper wheel, is because it was just as easy to do that than change it. Nice and solid. one doesn't need as much because we're going to be hitting over here. There, there's our horn ready to shape this piece. Here's also an important reference to do when you're trying to shape an ellipse on a horn and maintain that it's not twisted or out of alignment. So what we're going to do is use my curve mark, and we're going to set to 0 degrees and set the center. So we know exactly where dead center is on our horn. And then we know where to keep the center of our pattern or shape. So when we're hammering it or moving it around, it won't get, lopsided or twisted. And these are, like I said, giving reference points, clues. Because if you're out like this much, well, now your oval is going, on an angle on your auger. So when you weld it, you could get more pull on one side versus the other, and then actually bend the tube. We want to straighten it out. So this will help it align it much better. Now it's a little bit high, but then what I could do is make it a little lower. But here's where we're going to start. We're going to start with a dead blow hammer or a rubber mallet, and then you're hitting just over that edge and working it and keep working it, and then flip around and do the same, and you'll be able to make this, give it a nice curve, and you won't leave any hard imprints. So you're going to make it smooth in the inside. That's why we use a dead blow. Let's see if this works and we can get this straight. Take a hoodie off. Alright, well, cold working it works alright, but that takes a lot of time, a lot of noise. You get a little bit of shape. Let's heat it up, and this will take like a minute. So if you got the fire, use it. Half the plate, shake that, then we'll go the other. Watch the clamp, it's going to heat this up there. See it twist in my hand. plate. That's how you know you're getting the finish. If you get it nice and high, you just give it one whack. There it is. Lifting because it's expanding. The hotter the temperature, the more the expansion. See, just the gravity and the heat. Typically, when things get hot enough to work, they start to get a little glossy and finished, shinier. That's how you mash an edge. But see, we're almost a little too sharp. So, right. As I got it shaped pretty close to the tube, I'll peen it inside. And that'll tighten it up a bit. And if you want to smooth out some of the sharp edges that roll up, put her in and she straightens right out. You can come take a look at the cross section. It doesn't hurt as much. So here we are pretty close now. What we have to try to maintain is that we get an even bend. Now we'll do the same thing on the other side, and it'll make a lot different, and then we can more accurately shape. But right now, if I was to line up the center line, I'm a little high. So we've got most of the ripples out, if you can feel it. And now hit it, peen it along here lightly. Now this tube, when it's together, is strong enough, and I'm using a rubber mallet, so I'm actually not denting the pipe below. If I use a steel hammer, then I go through both. So this is just a quick way to size your sheet. And then when you work on an angle this way. Feels like we got a little twist, but I think we can take that out once we heat up the other side. Now let's see if we line up our marks and see how much it's off. That's not so bad. And once you get it real close and we shape it, we're going to have to dolly out the sides and try to heat it and stretch it to make it good again. And once we tack it up, then we may have to move it and dog it and tack it all together. Once it's all fitted, you can tap and heat and move, and you'll see this as we progress. So that's okay. I can heat up and do the other side now. A little hot. Flats on the top. Usually when I hit like this, I hit and pull, so it's actually like I'm grabbing the steel and trying to pull it down and smooth it this way, like you would move clay. Well, there you go. Pretty much rough shape of a section that we're going to cut out. So there you go. We've got our template all shaped pretty good. And once I cut it, shape it, form it, then we have to tack it all together, and we'll be able to tweak that size and get it to blend in. Remember, it's not going to be absolutely perfect, but the idea is to get it done, to never know it was there. So yeah, here it is. That's what it looks like. This is our replacement part. So rather than trying to track down a section of 16-inch auger tube, which is mucho dinero, we don't need to. We'll just replace the section that was damaged. So now we're going to go and mark it. Now what you're going to see is that this template seems to be not fitting. That's because we fitted it to the good pipe, and if you look, the pipe is still nice in its consistent shape. So because it's flattened and it's expanded, it's no longer round, but it's flat, so it's wider. We'll line up our center marks where these center marks are, run our chalk line, clean it up, run the chalk line again, cut that out with the plasma, and then we'll dolly off the other side to see if we can bring that pipe back or not. Then we'll set it on top again, mark it out, cut it, clean it, and that should be our final fit. And then we'll fit and tack it up. So that's how many more stages we got to go yet. So now we get to third stage. Whatever stage it is. Arrow. So we know which end is which. So we don't go, oh, fit it, flip it, mark it, and then we do our second cut and it's like, it's wrong. That can happen because remember, it's not perfectly symmetrical. It may have a twist. It may be, so make sure it stays in the right spot and keeps with that. And because you have a pattern, stick to the line. So technically, seeing that it's flattened and squished out, when you bring it in, you'll bring the material in and it will no longer fit. So you have to do a recut. That's perfect. On this, to relieve the stress, you got to do 2 cuts. You'll never get it in 1 cut unless it wasn't that bad to begin with. Now, this side, it's bad enough. Oops. No. Line up your center marks, and even if your other marks don't line up, that's okay. Always go by your pattern. There. Now that's what we're going to cut out. So I'll get my buffer. Oh, yeah. I want to take that paint off there because when I cut this, I want a nice clean crisp chalk line that I can follow. I don't want to lose the chalk line and gag on this smoke. I want to keep it as nice as we can. Alright, so I've already traced it, and you see I've got rid of all the paint where my marks are. So now we're going to remark it, and then cut it out with the plasma. And remember, facing in, like if you're inside, that doesn't matter. Remember, we're going for a recut, so goes by feel here. How does that look? Nice steady line, except for there. wonder why it doesn't seem like the plasma is going through, is because there's a nice coating of grain, gunk, and scale on the other side. So it's cutting through, and then, so you'll see once we cut it out, the first cut, and then we can clean and scrape all that old grain dust and residue off, and then the second cut's going to be so much nicer. Voila. A lot of the pipe actually popped out, and now the stress was relieved, and then we can find out where it is messed up. Let's clean this up again. And here's the inside of this auger tube, but look at all the scale from all that wheat, dirt. I mean, it's all stuck in there. So when you're trying to, you can't cut through dirt and grain. It doesn't work. And you can't weld to it either. So you want to make sure that you clean all the way around and then give the same treatment to the inside as you do the outside. So when you make your final cut, it's nice and clean, and your welds will be nice and clean as well. So, scrapey, scrapey. Next step, now we look at the inside of the pipe, inspect it for any dents or ripples. Usually when you cut it, it relieves that stress and boink, pops back to where it should. So now we're going to run a straight edge around it, see if any parts are dipped in or kinked, and if they are, then what we're going to use is plenishing hammer and dolly. So we'll fit it inside, just tink, 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 and massage that over and try to get it more true. Then we'll put our new piece of pipe on, remark it, recut it, re-clean it up, and then tack fit it and weld it, sand it down, call the customer, get paid, and do it all again in a couple hours. So now we got our 4-foot straight edge, and we get a good idea, and then we eyeball it, starting by center to end, and I see that I'm about 3/16 and 3/16, so I'm going to have to come up to here and to about here, and then we go every few inches and go, oh my goodness. That's good there. And now we go to here. And, see? Now we're dealing with the opposite. This is actually, should be coming down. Alright? That should come in. And this should have to come in. But all on this side is actually not bad. And we just got a little kink here. It's got to come up. It's got to go down. And now we look at the side. Not bad. Not bad at all. A couple little kinks. But you know what? I think that'll just pull out. Once we start tacking everything together, once we recut it again, it will heat up and ripple and stress and kind of sit where it wants to. We'll get it close, but once we cut it again, it'll help it, you know, relieve the tension all the way around. Like releasing it. This side's good, and then you're here to this side. So, you know, I know this is down, and then it just drops, because we're. So now it goes like that, and this is down, and this needs to go down, and this needs to come up. And now we are flat. Oh, look at that. We're a little high in the center. And then we're pretty much normal. So now if I want to see my low spot, here's my low spot here, and then it goes like this. So this whole area here needs to come up a little bit. See, there's a little gap. So all this little bit of area needs to come up. And when I recut it, this shouldn't be bad. So I might be able to do my mark right now, and then peen it after and do my final fit. Once we tack it all out, it'll ripple and shape, conform to it nicely. Untrain it on. It does. And we want this to be a little gap all the way around, but we don't want much because we don't want a huge weld. So now that we've got this shaped, see, we're so close. We've got to make sure we get our alignment. Hold it down. Be picky as you can be, and then holding pressure. It's actually pretty good. And we got a nice clean mark. Remember, if you end up and you have a gap, a 1/16 gap is really nice, because you don't want it to be perfectly tight, because you want somewhere for the weld to go, and ideally we want to put a root all the way through. That's when it's strongest. It won't crack out and bust. Makes it a little more difficult, but I mean, you do the setup right. So you want just a bit of room. You want, 1/16 clearance all the way around. So cut it as close to that line as you can, and then you go and you trim to fit. And then we know that it fits, and we'll start, when we put it together, we'll line up the dots, tack, tack, and then keep working it around, all the way around. And I'm thinking with the way it is, we may not have to dolly much of this before we put it together, because we can use the heat to bring it up. But usually when you weld, it's going to push it down. So any of the high spots, mark them off, save them for the weld, and we put the tacks on the high spots, and it'll push them down. The low spots, we'll bring them up and try to push them, like over bend them, so when we tack them, the heat of the weld will push it back in again. So that's how you can do your warpage control, because you don't want it to all sink. But just having this shape, it's going to be able to pull and actually pull and tighten to get this a lot, true again. Here you go. So that's how much that tube moved in after the first cut. So that's quite a bit. but you have enough. It doesn't move at the ends, but definitely on the sides. So you had just enough room to work with it. Remember, if you take all the scale and slag off the opposite side, when you make the new cut, it's nice and crisp, and you can do it a lot quicker. And it's more accurate. So we've got our final cut. We prepped it up, got rid of all our burrs, all the slag, all the scale from inside, prepped up ready to fit. Now the only thing that I said is we want this to be higher rather than lower, because when we weld, it'll actually push the tube in further. So by using this line and square, we figured out from here all the way down, and then from here all the way down, this actually has to come up. So we got two ways to do that. We can dolly it up, or be lazy, and we put the fire on it. Because if we put heat on here and expand it, this will lift, and it'll shrink because it's got to expand, right? So this end will lift up, and we can apply heat in this area, which should lift it up. Now we'll have to be careful and watch that it doesn't go down. If it goes down, well, then we have to get out a bigger hammer and straighten it out. But pretty much how heat works, it'll expand on the side that it's going, right? So if we heat it in here on the inside, it should, and then it will take its shape, and once it cools, it'll get nice and round, and then we tack it up. So letting the molecules do the work rather than, physically putting them in a line. We'll, have a sizzler party, and they'll have a couple drinks and relax. That's what the fire is about. kind of one of those feeling things. A little bit of patience. You know, you gotta let it heat, and it has to get down below 200. Now, if you want to cool, if you want to be able to move this a little faster, you'll get a wet rag and then you can control where it ripples and moves. But I think I want the heat in here for a longer duration so that the stress of the rolled pipe can, you know, pull it taut. Like the heat expands, but when it cools, it tightens up. So I want it to just give it time to let it take its shape back again. And then we'll clean this off, tack up our piece, and I think, look at that. We're a little low here still. We may have to heat that up again, but the other side is way closer. I think we might actually have to heat that, put a little water. I think we'll need a rag, and that'll just lift it up, pull it back. Now there may be a little shallowness or a flat spot in here, but that's not a concern, because in an auger, the most important part is the bottom. Is the bottom smooth? And you can tell by all the buildup that where the seam is from here to here, this is the bottom side, and it's actually really nice and really straight. So I'm not going to worry about this. This is actually above center on the side, so you know there's usually about a ½ inch gap either way, so it's never going to hit. And if we fold it up here in the corners, once we weld it, it'll actually probably pop it out, even it out. Not that you're going to notice a little ripple. So some things be worried about, but the most important part, spend the time on. If it's here, it's not that big a deal. But we'll peen it anyway. It's good not to throw junk out, because you need pieces of junk to tack to other pieces of junk to make things work. So I'm making a handle to hold it and somewhere to put my ground to. A couple little tacks. I got running the 024 wire, so I have a really short whip and a really short ground.
Easier to do, I use a thinner angular, thinner bar. Alright, now we've got everything fitted and tacked up. You can take a look at the fit up. Nice and tight here, which is nice. But we go over to the other side. Yeah, a little more gap that kind of sucks. And the only difference of that is if I had this whole thing shifted over like 1/16 of an inch, it would have been nice and even all the way. But it's not. We've got lots of tacks on and fitted it as close as we can. Once we weld it all, we'll sand it and try to get it as straight as we can. So now I just weld it up. The sides with the bigger gaps will probably stagger a little bit more. The side with the tighter gaps will keep it bzz, 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 so we can push that root all the way through. And we'll see how it goes. And for all the people out there wondering what I'm using to weld it, I've got a little 110 GMAW welder, and I'm running 0240 wire.
Alright, so we buzzed that in and burnt a root through all, you know. And now we'll remove all this welding. And you'll blend it in and you might not even know this was even there. I mean, that's the key. To never know that somebody was there. That's what you strive for anyways. Okay, well, we'll pull that up again. We're about 3/16 below on those sides. And then here we're straight. And here we're straight. We will actually raise this middle again. There you go. Not bad. That cool? And that's about as good as this auger is going to get. And that's how you patch a dent in an auger. Spray bomb to make it look good. A little red oxide primer. And then a little black spray paint over top. See you in hell.